Okay, good morning, everybody. Let's start. Okay, before forgetting, please use your online form to sign your names for the attendance right now. Okay, so last time we looked at this simple class, okay, day of year class. We said that it has two data members and one function member. And all the objects of this class that we define today and birthday are objects of this class, okay? And whenever we define it, in my memory, there will be an object created, and it will have two data member locations, month and day. I can store whatever I want in these data member locations for today and birthday. Note that I don't have any space for the function member inside the objects because the functions are all shared by the class objects. There is only one output function for the whole class day of year, okay? But each object of that class should have its own memory location, like that, okay? So we looked at this program and we said that today month, enter today day, etc. Then birthday month, birthday day. It's like using regular structs actually, no different than using regular structs. And we looked at these examples and I showed you some other stuff and we moved on, okay? And I showed you actually more than that. I think I showed you sure.
Can we define member function of class before define class?
Yeah, the order is not important. You can define your data members or function members in any order. The compiler will say it is okay. But our usual, what's going on? Our usual ordering is usually we define our public functions first, then private data members and the private functions later, okay? So this is what we do actually. As you see, I think this is the last time this is the last time I gave you, right? So we said that input and output are public member functions, equals and greater than equal to, etc. These are all public member functions, and then we have our private. It is okay to have this at the beginning. The compiler will have no objections to this.
I'm not asking that. I'm asking that if we can define implementation of member functions before definition of class, outside of scope of that class, before scope of class.
How you mean? Oh, you mean? Can I move this one to the? The answer is of course not. How would the compiler know that there is a class day of year and there is a function named input in it to I mean, of course it is not possible. But I mean, I mistook your question, but this comes often too. Is there any ordering of the private and public sections or the ordering of any data members and etc.? The answer is no. You can order it the any way you like, because this position is not for implementation, right? And this is only you are saying that I have this data member, I have this function, and etc. They are not using each other yet. Okay. When we start implementing them, then there's going to be another issue there. Okay. So we looked at this one. Let me put it back to original form. We usually in C++ we usually do it this way. We list our public stuff first, then the private later, because private is something to do with, as a developer, with my business. Okay. my users, my customers, they are not supposed to look at this private section. Okay, they are supposed to read this part first and use this class accordingly. That's why we try to kind of hide the last part of the class definition from the customer. Of course, it is not hidden, but we don't show it at the beginning. We say that important thing for you is here. So we put the most important stuff at the top. Okay. So we looked at this one, and can anybody tell me the difference between this const and this const? What is the difference between these two const keywords? Yeah. Since nobody else raises their hand, then yeah.
Second const promises not to change data of color object. First const is promises not to change day of year.
Okay, did you hear? No, they did not hear you. This one is for, we say that.
It is for, it promises us to not to change data of color object.
Yeah. When there is a const here, this function is a const function. And what was the name of the equals? Yeah. When we run our main function, wherever it is, where is our, yeah, it is here, it's main. When we say today dot equals, okay, so this equals says that I am not going to change this object total. It will stay the same after I run. But equals also says that, this equals also says that I am not going to change the parameter I am receiving either, okay? So two things it promises. Let's say that I am not going to change, okay, this birthday. This is the constant parameter. And also it says that I am not going to change this today. Two things that it promises not to do. And compiler knows it. Okay, compiler knows that if this function changes this object's data or day of year, the parameter other object's data, then it will produce a compiler error.
Is it possible for today to be changed? You said today cannot be changed.
Why not? The input changes today, right? When you say today that input, it changes input today, right? That's why it is not const.
So it depends on input.
What?
So it depends on input.
What do you mean it depends on the function? Output says that I am not going to change this object, okay? Input says that I will change it, okay? I may change it or, okay? But in C++, we say that whenever I say it, okay? Whenever I say this such a, okay, question for you. Inside the output, if I change my object, compiler will give me an error message, right? That's true. If input, inside input, if I don't change my object, would compiler give me an error message saying that you didn't change this object, but you are not const? No. Okay, it is okay. If you don't want to change it, don't change it. But if a function does not change an object, then you should declare it as const. What did we say? The principle of least privilege. Okay. If you are not going to change it, then make it a const. Otherwise, the compiler cannot help you. So when I look at this one, there is only one and two functions that will do this change. Okay, all the others are constant functions. Okay, all the others are constant functions. Good. Okay, so let's move on with our slides. We already know this, dot and scope resolution operators. Dot is this, right? When you say today dot output, this is the dot operator. But remember the scope resolution operator when you say day of year and I am going to implement this input function inside day of year and dot dot dot, right? So this is dot operator, this is scope resolution operator. Specifies what class the function definition comes from. Input is not a global function, it's a member function of class day of year. Okay, yeah.
Can we only call member function by the scope resolution operator from in class?
From well, if you are inside a class, whenever you call the function input, it will work, right? So you don't, for example, let's go to, okay, let me do this then maybe, okay? Let's go to function output or input maybe. Where is my input? The input is here. So after I get all this data, I can write output and it will work.
Can we call in main like day of year resolution operator?
Of course not. Where is your object?
I'm asking that because we do things like STD resolution operators, like.
Well, I mean, the same thing. I mean, where is your object? We cannot say in your main, when you say, we will come to that later, but, okay. If we go to main, okay, and I am trying to do this, okay, the compiler will tell you that input needs an object, okay. Where is, I mean, remember input needs month and day, right? Where is my month and day? You didn't declare an object, so you are trying to run this like a global function, and this is a compiler error.
If input doesn't depend on any data from class.
Still, I mean, you need an object to call a function. There are these kind of calling styles, and we will see them later, but those are very special functions. Those are not like the functions that we did, okay? So let's go back to my question. Okay, so since this is okay, if I can find my input, where is my input? Here it is, okay? I could do this, right? No problem. So, and it is kind of intuitive too. Whatever I am inputting from the keyboard, I am outputting it right now, right? No problem, this will work. How about the other way of doing stuff? Let's say, well, this is not intuitive, but I want to do this. Can I do this? I am not talking about would this be a logical thing or should anybody do it. I'm asking about, is it permissible by the compiler and the language? Why?
Because it's a const function and input is not const.
Yeah, because output is a const function. It promises that it's not going to modify this object, but input is a function that modifies this object. So the compiler will not let you do this. Okay, it says that this is a non-const function. Okay, so I will not let you call this one here. So this one is okay, but this one is not okay. Const functions, they cannot call non-const functions, but non-const functions can call const functions. Okay? Yes? The function equals? Yes. Definition? Where is my the equal? Yeah, there. Okay, here it is. Yeah. This is my parameter that I am comparing with. But this is other, yeah. Other is my parameter. Other month and other day, I am comparing it with myself. You mean this one? Well, remember, I only wrote this one to give you an example for a global function. This is not a member of the class. This is a global function. This is a function that you know how to write from your C course, okay? We don't like these kind of functions at 136. This is a global function. This global function takes two parameters, right? And these two parameters will come from the outside. there is no classes, there is no object, there is no membership, etc. So, but I'm just saying that this way of writing and this way of writing probably will produce the same assembly code, but in object-oriented programming world, we don't like global functions. Yes?
Can I create a class that named main? Can I create a class that named main?
Can you do your class what? I don't understand. Say it louder.
I want to make a class.
You like to make a new class? Yes.
I want to set this name as main.
Main.
Yes. I want to.
Well, main is not a C++ keyword, right? I mean, where is my main? Int is a C++ keyword. Bool is a C++ keyword. Private is a C++ keyword, but main is not. As you see, it is not in bold. Well, can I make it larger? Not much, maybe. So main is not in bold, right? Main is not a C++ keyword. Yes, in theory, you could, but in that case, you won't have any compilable programs or executable programs because the operating system needs a function named main. Since we have a class named main, you cannot make another function named main. So, no, the short answer is, in practice, no, but in theory, yeah. That would be a not very useful class, but yeah. So did I understand your question right? You are saying that, can I name my class main? Well, yeah, okay. Yeah, of course, why not? You can have a function named printf in C, right? You can write it as long as you don't use the as long as you don't use the standard library at all, because standard library defines another printf, right? So printf is not part of the core C language. It is part of the standard library. Main is like that. Okay, let's move on. Everybody is done with the attendance, right? Did everybody? What? Any other people? Okay, you are going to see me after the second class. Let me read some names. Why don't we do this? I mean, somebody remind us that it is the last 5 minutes of the attendance. And we all sign our names at the same time. But I remind you, right? Didn't I remind you? So that means that that's not going to be useful either. Okay. Sare Nur. Pelin. Ziya Kadir. Anıl. Muhammed Şükrü. Ziya Kadir. 2 defa mı var Ziya Kadir ya? 2 defa mı okudum? Nerede Ziya Kadir? 2 defa mı girdin ismine? Niye?
Hocam tam o sonra internet olsun diye deniyorum onun da.
Numaran da aynı, ha? Tamam. Selim Aynigül. Ahmet Faruk. Okay, today is 17th. Let's go to the first person. 17th. Okay. Ali Erdem. Ali Erdem is the first person today to sign his name. It took him only 14 seconds. So 14 is the record? I guess 14 is the record, yeah. Okay, good. Let's see if anybody is going to get that record less than 14. So let's go to the slides again. We looked at this. Class is like, as we said, is like a new type, right? When you define a class, it becomes a new type, okay, like an integer. And like we are using the types, we can define their variables. Now we call them objects. So in standard C++ terminology or C terminology, okay, this is our type name and this is our variable, right? But in C++, in object-oriented languages, day of year, today, when I say this is our class name and this is our object, okay? Class and object, type and variable. And most of the time I use these terms interchangeably, and I will call this a class, I will call this an object. In fact, I shouldn't, but I do this from time to time. This is still a type. This is a fundamental type. This is a class. Okay, so I can use this. C++ says that. Okay, most of the time you can use your classes like regular types, like integers and everything. Okay, like I did with the variables, I can pass them by value, by reference. I can take pointers of them. I can define arrays of them, and etc. Everything, whenever I can use an integer, I can use a day of year. Okay. Then we talked about this, the principle of encapsulation. Okay. You put your data in a capsule, and we used to call it a struct, right? So all the related data about something is coming together, and we call that a struct. Now we are putting operations that will work on that data, and we put them in the same capsule, and we call them classes. This idea is called encapsulation. Okay, any data type includes this data and the operations. Okay, integer kind of does that. Okay, for an integer, data is stored as like 4 bytes or 8 bytes, depending on your hardware, and all the operations such as the plus, minus, multiplication, and etc. They will work on that data, and they are all defined. Same with the classes. Okay, we specify our data and the other operations on that data, like we did for the day of year class. Okay, abstract data type is exactly like that. Okay, usually we call it ADT. The programmers don't know its details, they only see its interface. Okay, like we see the interface of the integer class, right? We see the plus, minus, multiplication, but we don't know how the integer is represented. We don't have to know most of the time, and we don't know how the multiplication works, how the division works. Okay, we just keep using it. It is shortened as ADT. This is a collection of data values together with a set of operations, and ADTs are often language independent. Okay, integer is an integer both in C and Java and C# and whatever language you use it. This class, remember string? We have exactly the same thing in Java. Its name is string. It is used the same way, other than the ways of using Java. Okay, and they implement their string class, of course, in a very, very different way, but it behaves the same thing. Okay, so it's called abstract data type. It's like, I give this analogy a lot. It's like using a car, automobile, right? Doesn't matter what kind of car you have. It's an electric car, or it's a, let's say, a diesel car or the gas car. Doesn't matter. There is a steering wheel, okay? There is an accelerator. There is a brake pedal, and it has door handles, and it has wipers and etc. The interface is the same. You use the car the same way, but first you don't know how the car works. You don't have to know, and you don't want to know. The second is, whatever your car is, you use it in the same way. You follow the same rules in the traffic. Okay. So different technologies produce the same way behaving cars. Okay, encapsulation is bringing together as one, put them in the same capsule. Okay, you put the data, you put the operations working on that data, and you close your data and the privates to the outside world. You say that, okay, this is my business. You are not going to modify any of this data. And these are some of the fundamental principles of object-oriented programming. Information hiding, okay? Data abstraction, encapsulation. Information hiding is details of how the operations work not known to the user. The user doesn't know how the things work. When I hit the accelerator pedal or gas pedal, okay, I don't know how the car accelerates, but it accelerates. I know that. Okay. When you call the plus operator on two strings S1 and S2, I don't know how this plus operator works, but I know what it does. It puts together these two strings and it gives me another string. Or if I say double 1 times double 2, I don't know how to multiply doubles with exponents and multis and etc. Okay, but I know the final result. This will be the regular multiplication of two doubles. So that's called the information hiding, and we try to do this in our implementation of our classes. Data abstraction is details of how data is manipulated within ADT, abstract data type, not known to the user. So data abstraction and information hiding, as you see, is very, very related. Data abstraction is kind of more general. It says, I don't know what data I keep. I don't know how I represent my string. Okay, I don't know how I represent how the double is represented within the class. Okay, it is abstracted away from me. So abstraction is something that we use all the time in our daily life, in our engineering life, in our science life. Okay, and we are going to use this principle a lot. And then encapsulation, as we have seen a few minutes ago, bringing together data and operations. So follow these three principles. Okay, you are on your way to become a good object-oriented programmer. There will be a few more principles, and if you follow them, then you are writing object-oriented programs. You don't need C++, you don't need Java, you don't need any high-level programming language. If you follow these principles, even in assembly, you are supposed to be writing object-oriented programs. Doesn't matter. So why are we learning C++ and Java then? C++ and Java are very useful in letting us enforce these kind of principles. It say that you want to do the encapsulation. Okay, I'm going to give you something named class. Put everything in a class. Make the public and private sections properly. And here is your encapsulation principle. So if somebody doesn't follow this encapsulation principle, as a compiler, I'll give you an error message. So I will be helpful for you. Okay. If I'm trying to follow the object-oriented programming principles in assembly, my assembler will not give me any help, because the assembler doesn't know what an object-oriented programming is. Okay, but I know it. If I follow all these principles, then I'm an object-oriented programmer using assembly. How many people does that? Well, I don't know many, but I know many people, many companies doing object-oriented programming principles in C. Okay, they always say that, okay, this function is private, nobody should call it. Okay, they put it in the comments, and they say that this parameter is a constant parameter, nobody should change it. Okay, these are my data in a struct, nobody is supposed to change this data, etc. So you put those rules and everybody follows those rules, and you are an object-oriented programmer. If somebody breaks one of those rules in C, object-oriented programming rules, the compiler will not help you to give you that message. Only in code review, when your peers review your code, they will tell you that, okay, you violated one of the object-oriented programming rules. Okay, good. Public and private members, we talked about those. As I said before, the compiler is going to help me. In implementing this principle, information hiding. Hide whatever is supposed to not known by the user, by the customer. So there is a public section in a class and private section in a class. We say that, okay, in day of year, these two functions are public. Customers of this class can use them freely, but these two data members are not public. They are private. So nobody outside of this class has access to these two data members. So I enforce this principle of information hiding, hide the data from the outside world. And I am telling that compiler that if somebody violates this rule, produce an error message. Okay. If I do this, of course, from now on, these two statements will not be possible for my customers. It will be possible, these two, input and output, because they are public. Okay, by the way, I can do this. I mean, I don't have a single public section or private section. I can define a public section, then private section, then a public section. Usually, I don't prefer it this way, but from time to time, you are going to see it. Sometimes I like to make a kind of a public section after the private. Remember why we keep the privates at the end? We kind of put them away from the user's eye, right? We say that, okay, this is the place that you need to look at. Let's ignore this part. But how about this part? It is at the end. We usually put this part, put functions in this part for deprecated functions. Deprecated function is this. I had a version of this class A before. It has this function, f1. In later versions of this class, I decided that I should not use this function f1 anymore, okay? I like to take it away from the customer, but if I do that, the customer's code will break. It will not compile. Then I put this f1 at the end of this class definition in a public section, and I put a comment at the beginning. I'm saying that these functions are deprecated, okay? Don't use them, but if you have old code that is using this function f1, then it has to be here, otherwise the code will not compile. So it's kind of, I am trying to hide away these kind of functions. So all I am saying is that public and private, you can mix and match public and private, but usually in C++, we list the publics at the beginning and privates later. Okay. We like to categorize our functions like accessor and mutator functions. As the name implies, some functions they modify our objects, some functions they don't. So mutator functions are the functions that modify our objects, like input. Input modifies our object. Accessor functions are getters, okay? They get the value for you. They do something with the class, but they don't modify it, okay? So we call them accessor or mutator functions, or sometimes we call these getters and setters, okay? And usually for each data, we provide getter and setter. But the thing is that, I mean, you might say that, I mean, is getter and setter is kind of violating the rule of information hiding, because you are showing whatever I have as data to the outside world. But if you really think that that data should not be visible at all to the outside world, then you don't write a getter, okay? And you don't have to write a getter for each data member of your class. And when you do the setting, you set it very carefully. You say that I am going to set this only with these conditions. Remember how we wrote the set day? Set day is written this way. I am going to set this day only if day is greater than 0 and d is greater than 0 and d is less than 32. Otherwise, I will ignore whatever you said. Okay? This is a setter, and it is doing it in a controlled way. Getter is doing it. Getter is doing it regularly, returning a day. Since I have an integer as a day, I can return it. But if I keep my months and days in a string, for example, I may prefer it this way, then my getter will be a little bit more complicated. I will have to get that day part from the string and convert it to an integer and return it. Okay, so implementation is something I have to do. The customer doesn't know about it. All the customer knows that whenever they call this get day, it will not modify the object and it will return an integer. The customer doesn't know that I am keeping that integer inside my class. I may not, or I may change my mind later and implement this class in a different way. Okay, we talked about that, and somebody asked this some time ago. We usually keep our interface and implementations at different locations, like this one. Okay, so this class is my interface. Okay, it only includes the definitions of my public functions. Okay, the user is not supposed to know how input works. It knows what input does, but it doesn't know how it works, or how equals works, or how next day works. Well, you might say that you have implemented this function inside the class. Well, I shouldn't have done that way, or this one. Sometimes if a function is very, very simple, okay, we implemented within the class definition. That's kind of the customary for C++, just to save a few keystrokes when you write it as a separate function implementation. But these functions are very, very simple, and everybody kind of guesses how they work. Okay, so this is my interface. I put it in at the beginning of the file. Then these are my implementations. So that's the called separation of interface and implementation. But I did it that way, and I put my main function in the same file too. Usually in our daily life, we do it this way. Okay, we define a header file, dayofyear.h. Inside that header file, dayofyear.h, I have the class definition like class dayofyear ... at the end and the semicolon. Okay, and then I define and I implement my dayofyear.cpp, a C++ function file. Okay, I include dayofyear.h and I implement everything in there. So two files. One is for the header file, one is for the implementation file. And of course, I send this header file to the customer so that they can include it. And I don't send this implementation part. I only send the compiled version of it, which would be dayofyear.o. Okay, dayofyear.o is the compiled version of this file, right? I send this file to the customer so that they can link their code with my library. Or better yet, I can make a large library out of my classes and send the library, and they can use the library as they wish. Okay, so that way implementation of a class stays hidden. By hidden, as I said, I am going to stress this out once more. We don't mean that it is for security reasons, okay? It is hidden because of the information hiding principle. We are following that principle. Okay, my customer should not know or doesn't have to know the details of my implementation to be able to use my class. Okay, my class header is there. All they have to know is this, nothing else. Okay, this part. And of course, I should write nice comments next to each function, and that will be it. Nothing else more than that. So implementation of class is hidden. So I am not sending my code to the customer. Even if I do, they are not supposed to look at inside this CPP file. Okay, any questions up to now? Yes.
If I don't write any access,
If you don't write any,
if I don't write any access modifier public or private, would it be public by default?
oh, okay, I am just talking about that, okay? So that's the thing. So for the classes, for the structures, okay, remember when we wrote the structures first, let me find that one. The first chapter, this one. Yes, see, this is a struct, you don't see any publics and privates. And in fact, in C++, it is possible to have public struct parts, and it is possible to have private struct parts. Okay? So you might say, how come we didn't write it? That's because in C++, all the members of a struct by default, they are all public. So you don't have to write it. Just delete it, okay? So all of them are by default public. But when it comes to classes, all the members of a class are by default private, okay? So if I don't write this public here, this input, output equals, etc., they all become by default private, okay? So that's one of the differences between structs and classes, okay? In classes, everything, if you don't specify them as public, they become private, okay? In structures, everything by default public. By the way, you may add function members to structures in C++. Structures can have their own functions. But usually, as I said before, we don't use structures much. We use classes. So they are technically the same. I mean, we could have lived, okay, with structures in C++ without the classes, and still can do the object-oriented programming, because structures can have their own public and private parts and etc. But they have invented this new keyword class, and we are more compatible with the other object-oriented programming languages like Java and Smalltalk and whatever. Okay, class is kind of a standard term for all the object-oriented programming languages. Yeah.
Is all member functions of classes are called public?
What did I say? All the members of a class are private members. Function and data. Okay. Member means that it's a member, right? If you don't specify it, okay, by default they are private. For the structures, if you don't specify they are all public. But usually for the classes, we declare our data members private and we declare our functions public. But I mean, this is just a very trivial generalization. We are going to see some classes that will have private functions, and we are going to see some classes that will have public data members. Okay, that's not the rule. It's just typical. Okay, good. So thinking objects, I mean, it's something that is very intuitive actually. As I said before, it kind of, first it comes as confusing, but later you get used to it. Okay, Before the object-oriented programming, when you do the C programs, it was the algorithms that you are after. You write functions, and function means an algorithm. You are implementing you are implementing a function, and function is supposed to do something, and the functions are building blocks of your program, right? In C. In C++, data is at the center. You talk about your data. You say that I am going to have a customer, okay? This customer can do deposit money, withdraw money, print its name, okay, modify its name, get its name, set its name, and etc. So you are always talking about the data of a customer, and you are doing stuff about that one. So object-oriented programming, you specify your data and you specify your algorithms around that data. Algorithms are still there, but algorithms are there to modify that data. Okay, so whenever you design a new system, you immediately start talking about your classes, and classes about your data, right? And when you have your data, your functions that will work on data will be specified later. That is how you do object-oriented programming. By the way, we are teaching object-oriented programming languages in this course. Object-oriented programming or system design is something different. Well, of course, it uses object-oriented ideas, object-oriented programming languages, but it is more than just using an object-oriented programming language. Okay, so object-oriented design, object-oriented software engineering, you are going to learn it in your third year at this department. It uses all of these ideas that we are teaching you, but it focuses more on the design part of a software. Okay, so that will be it for this chapter number 6. Are there any questions about what did we do? What did we do? We did this. We talked about structure, then we made our classes, and we talked about public and private. And we talked about the classes being like new types, and objects are like our variables, and etc. Okay, and for a C++ program, we always talk about the interface of the classes and the implementation of the classes. Did I show you all the programs? Chapter number 6. Chapter number 6 and maybe number 4. Yeah, I think we did that, right? No, we did not. Okay, let's look at this one. Day of your class, of course, our month and day here. Input, output, set. See, set is overloaded. Okay, set is overloaded. One of them takes just a month. Okay, I am setting the month. The other one takes both of them. There are two gets. One is for the month, one is for the day. Input and output is here, and main is used this way. Our set is more involved now. If it is between, yeah, okay. See this one? Well, I mean, since the set doesn't return any integers to indicate that there is an error or something like that, if there is an error, it just terminates the program. Remember my solution? My solution ignored the input. If the data is invalid, I ignore the input. This one terminates the program. Of course, instead of C out, C error would have been a better option. Say it again.
Can we use return 1 or 0 instead of exit 0?
Well, yeah, you need to return 1 or 0 to indicate an error. When in that case, it cannot be a void. It has to be an integer, and you need to document it in the header. We have a better solution in the name of exceptions, okay? But we will see it at the end of the semester. Set is doing the same thing. This one is for the first overload. Okay, this is first overload and the second overload. Overloading is something nice. that we are going to use all the time in C++. Okay, that's the end of the chapter number 6. Let's take some break. After the break, we will start our chapter number 7, which is more about classes.
Hocam ben girerken sistemde bir hata oldu. Sorun oluşturdu da.
Geçen sefer de mi sende hata vardı?
Ben geçen sefer bilmiyordum olayı. Çalıştığım için o gün gelememiştim de öyle söylemiştiniz. Sorun oluşturdu basamadım hocam.
Ne sorun neymiş?
Bilmiyorum yani 2-3 kere denedim. Bir kere daha denedim yanıt kabul etmiyordu. Bir kere daha bir sorun oluşturdu.
Geç girmişsin.
Ama
Kaçta girdin?
10 dakikası vardı.
Kaçta girdin?
44'ten basmaya başladım. 44, 45, 44.
Ya
8.44'te basmaya başladım.
8.30'da başlıyoruz biz.
Ben basmaya o an bastım. İnternette
8.30'da başlıyoruz.
İnternette sorun olunca
İnternette ne sorun var? Sorun yok ki internette.
benim hocam kendi internette sorun oldu ama basamadım. İnternetim gidip geldi bir şeyler oldu.
Senin internetle alakası yok ki sen var. Bizim
Ben Wi-Fi bağlı değilim hocam.
bağla öyleyse.
Bilgisayarım işte ben bir hata oldu.
Tamam, getir sefer yaparsın. Şimdi play noktayı satıyor ya. O input play'e değiştirecek değil mi?
Abi bir baksana.
Bakıp hiçbir şey öğrenmedim.
Şöyle bir resmimiz var ve bundan hiç pişman değilim.
Çok iyi. Sağın önüne
Korkunç o ya. Hepsi minibüslerin şerefsiz.
aynen öyle kafa yapıyorsun.
Her şeyde.
Tat var ya tat.
Okay. So we will continue learning about classes. Classes are the main blocks of object-oriented programming languages, as we said. But they are not the only things, okay? Within a class, there are many useful tools for us to write object-oriented programming. What are you doing? Within a class, there are many tools that an object-oriented programming language offers us, and we like to use them. And as you see, they are very useful. Again, each of them will be very simple tool, very easy to understand, very easy to tell. The complication comes from there are many of them, and when you use them in combination, it might become a little bit more involved. Okay. Could you turn off your computer? Yeah, I'm talking about you. Turn off your computer. Yeah. The attendance is not on yet. It will start at 9:45 in the second hour. It starts at 9:45. It ends at 10. Okay. That's because usually I am late in giving you the break. When we come back, it is way past 9:30. That's why we chose that way. So attendance will start in 5 minutes. So remind me again that the attendance has started, and I will remind the class. Okay, one way to look at these classes are like, we say that in real life, this is a classical example. Classes are like blueprints of buildings, okay? Binaların planı gibi, mimarlık planı. Okay? Classes are blueprints, objects are the buildings themselves. Okay? You have a blueprint of a building, okay? You design the blueprint and you spend lots of hours working on it. You give lots of thoughts about what should be what, how many rooms and how many floors, where is the entrance, where is the fire escape, how about the air conditioning and etc. How about the air conditioning and etc. So blueprint is just a piece of paper, right? It is not the building itself, but it is very expensive to draw because lots of engineering work goes into it. Once the blueprint is ready, you make lots of buildings out of that blueprint, okay? So you make a building using the same blueprint, another building, and thousands of buildings, okay? So classes are like blueprint. They are very abstract stuff, just pieces of paper, but objects are real buildings, and they are concrete. They are not abstract anymore. They occupy space in the landscape, and people live in it. They are useful stuff. Without the blueprints, you cannot build the buildings, right? You need the blueprints first, and blueprints has to be designed very, very carefully. That's how we. This is an analogy that we keep using to tell you about the classes and objects. Okay, so you are saying that I need two buildings, D1 and D2. Okay, day of year will be the blueprint of these two buildings. Okay, and the compiler will give me, okay, on my memory, it's going to produce a code for two objects, two buildings. Okay, it will construct two objects. I will construct a building. Okay, so that's an analogy. In this chapter, we are going to talk about constructors. Is a special function constructor, and then const parameter. We talked about that. Static members of data and the functions, inline functions, and many examples of C++ programs. Okay, constructors are, okay, we are defining constructors. Constructors are simply functions, member functions, but they are special functions, okay? They are special functions. Let's look at this, our typical C code. When I say integer I, right? Integer I, okay? I have some space in memory, and what kind of initial value I have in it, I don't know, okay? So it's a junk value in it. If I have this statement though, 2, then it has 2 in it, right? It is initialized, so it is nice, okay? How about this one? Day of year, D1. When I say day of year, D1 will be something like this. It has two fields in it, data members in it, month and day, right? What are their initial values? I don't know, right? It is garbage. In object-oriented world, we don't like these kind of objects, okay? If I define an object, if I have an object, I should always know what is in it. So by coincidence, there could be -2 and -7 in it, right? Because this is garbage, right? I don't know what is in it. Usually there is 0, but it doesn't have to be 0. From time to time, it might be some garbage values. So it is -2 and -7. And when I run this d1.output, okay, this one will crash, right? It's going to say, -7 is not a regular month name. I cannot print it. So I will quit my program. Remember, I think it was like that. I think it was, I don't remember yeah, it says an error message, but it doesn't exit. Usually we would exit if I hit here, right? So not nice things will happen if I do this, okay? And in object-oriented world, we don't like this kind of stuff. We don't like this kind of stuff happening. We say that if there is an object living in my memory, it should be always in a valid state. I should make sure that my objects are always in valid state. Okay, so what am I going to do? Then you might say that, why don't you use your setters then? d1.set 7.2. Well, yeah, that's true, but how about between these two lines? I will have an object who doesn't have any valid values in it. So to prevent this, they have invented this way. They say that there is a special function named constructor. Constructor will be called automatically whenever you construct a new object. Okay? Constructor function will be called automatically whenever you construct a new object. So when you say day of year D1, that constructor function will be called, and you may initialize your data if you implement that constructor function. That's what the constructor is. And immediately I will give you a constructor. Why don't I show you the real code from the book, chapter 7. Okay, let me open it. Open 7.1. Okay. Here is one constructor. Let's look at this one. A constructor that doesn't take any parameters. And when you say, let's ignore these, day of year, D1, okay. When the compiler compiles this line 38, it will immediately call this day of year function, okay. And let's look at the implementation of the day of year. Day of year function, I didn't like this, okay, maybe it has too many unknown stuff in it. That day of year function will initialize my day of year to 1, 1. Month and day will be both 1 and 1. Okay. So when you say date 1 and date 2, okay, it will call that function, and that function will initialize 1 and 1. You might say that, well, I don't want to do it that way. I want to provide initial values to my constructor. In that case, you are going to write a constructor like this. Okay? You will say that, okay, my constructor will take 2 parameters. So it's going to be like this. Day of year D1, okay, month of June 21st. Okay, I am initializing this D1 with month 6, day 21, and definitely after this D1 dot output will print this one on the screen. If I try to, using this code, if I try to make an object like this, day of year D2 semicolon, the compiler will give me an error message. It will say that to make a new object, to construct a new object, out of this class, okay, I need to call the constructor, but the constructor needs 2 parameters. This one, you are not providing any parameters, right? So this will be an error message. because there are no constructors that will take a 0 parameter. Okay, so that will be an error message now. So I am kind of forcing my customer to initialize my day of year objects with 2 numbers.
Can't we overload construct function?
If we like to make this possible, yes, you need to overload this day of year with 0 parameters, no parameter constructor. Then in that case it will be called. But in this case, this will not be possible. Okay. Of course, if you overload it, it will work. So let me go back to my example from the book. Book says that I have 3 overloads for the day of year. I can work with day of year D1 or day of year just one value, month. It's going to take just month and the day will be the first of that month, or I can take both. So overloading is nice. See, I mean, when I introduced this overloading thing some time ago, it was kind of a, well, this is not nice, but I don't have to have it. It is not that useful. From time to time, I might use it. With the classes, especially with the constructors, we use overloading a lot. Okay, I overload my day of year constructor, and it will work. And I didn't talk about the constructors much in terms of their syntax. Their names has to be the same as the class name. So this is a constructor, constructor, constructor. It's a function, but its name has to be the same as the class name. That's how the compiler knows that this is a constructor definition. Okay, it's a constructor definition. And constructors doesn't return anything, not even void. Okay, void is something. Okay, is a type, right? When you say I am returning void, that means that I am not going to return a value, but you are returning a void. Constructor doesn't return anything, not even void. Okay, it doesn't return anything. That's how they are written, and usually they are listed at the beginning of your public section. When you say public, day of year, day of year, day of year. Okay, these are your constructors. After the constructors, you have your input, output, get month, number, get day, etc. Good. Yes.
So when we use constructors, don't we need setters anymore?
It's a good question. I mean, if I have a constructor, do I need a setter? Well, I mean, after you construct your object, later you want to change some of the values. For example, you might say next day, make me next day, increment the day by 1, and etc. Yeah, well, usually you need it. But definitely you don't have to write things like this. You don't have to say, after making the object, after constructing the object, you set it later. Then you don't have to do that, because you put a parenthesis there and 7,2. That will set you. Okay. Construct an object and set later. You don't have to do this. You immediately, while you are constructing your object, you are initializing it. That's called initializing your object. And we are, what did the book say? Book says that, okay, automatically called when the object declared. Very useful tool, and we use it for initializing our data. Okay, if we have member variables in our class, and since I am being constructed by the compiler, I am saying that while I am being constructed, I am going to initialize that member data. Otherwise, nobody knows what kind of data member values I have. It's a very flexible, very useful tool for us. Remember, okay, constructors and other tools. It's a tool that this object-oriented programming language provides for us. Okay, you don't have to have a constructor. You don't have to have a constructor to write object-oriented programming code. All you do is you make it necessary for your customers to do this. You say that whenever you make a new object out of me, my class, then you immediately initialize afterwards. And you follow these rules. If they don't follow, then they are not writing the object-oriented program. But I mean, we are all humans. If we make a mistake, and if we did not initialize our data, then nobody will help them. But with the help of the constructors, you will never have any uninitialized objects living in my memory. Okay, good. So what do I have inside my constructors? Okay, implementation is very simple. It is this. Day of year, this looks weird, right? I mean, day of year, and this, because it doesn't have a return type. Yeah, but this is how you know that you are writing a constructor. I assigned month value to month and day value to day. Okay. Well, it looks like they are not doing any validity check. If somebody wants to set this month value to -15 and day value to 225, right? Oh, did everybody sign their names online? Okay, just do it now. Wake him up. Did he sign his name before he sleep? Before you went to sleep? Then you go back to sleep. Is he going back to sleep? No, okay. This is not good because, I mean, I'm not doing validity check. I think much better solution would have been this, right? Set month value and day value, right? Remember, set is checks month value and day value, right? Set function. So I am using my set function. I already have it. So I am setting something to more meaningful. If these two values are valid, then I am fine. If it's not valid, whatever the set behavior is, I am going to get it. Okay, I am going to get it. So no return type. That's one thing. Same name as the class. That's how the compiler knows that you are writing a constructor. Other than that, it's a regular function. It takes parameters, it is implemented, and it runs. As I said before, it is the first thing that the object does when it is constructed. That's why it is called constructor function. Constructor function. An alternative definition would be this. Okay, I take two parameters. I say that I am going to initialize my month with the month value, like this. And I am going to initialize day with the day value. And I don't write anything in the braces. This is called the initialization section. Okay. Without writing any code inside my function body, I am initializing my data members this way. Month value, day value. That's it. Of course, you might say that, well, this is not doing any validity checks and etc. Yeah, that's true, but maybe I can put some lines in there and etc. But this is how you do the initialization. So this is called the initialization section. If you like to initialize your data members directly, then we use the initialization section, and we like this initialization section a lot. Okay, we like this initialization section a lot because it is a little bit more efficient than putting the initialization statements inside the braces, inside the function body. Okay, this is preferable definition version. No, okay, after all of that, let's go to this class, day of year. Okay, input and output is here and get number is here. We are not going to list all the functions that we have seen for this class because it kind of gets crowded, so we are kind of simplifying it. Okay, so I have 3 constructors. I have input and output, and I didn't use that const keywords yet. Okay, but we are going to, let's put it const keywords. Output is a const, right? And get number is a const 2. Get day is a const or non-const? Should I put a const or no const? How about this one? Constructors can never be const functions because, as the name implies, they are constructors. They are supposed to modify something. There are no const constructors. And I believe it's a compiler error. You might say that my constructor is empty, it doesn't modify anything. Still, compiler may not allow this. So this cannot be const. Input is not a const. How about getDay? Is getDay a const or non-const? Of course, it's a const. Okay. And in our private data, oh, okay, this is good. See this one? There is a private function. This is the first time happening, right? This is the first time that we have a private function. Before this, okay, before this, all the functions were public and our customers were allowed to use them. Now, this test date is not accessible from the customer. It is something private. As the name implies, we are going to call it in our setters or in our constructors to see if the given date is valid or not. Okay? Good. So this one says that make me 100 date objects. Okay, let's ignore this one first. Let me put it in here. Okay. Okay, this one says that I am going to make an object named date1, and while constructing this object, you are going to call this constructor that will take 2 parameters. Okay? So it looks like I am going to initialize them with 2 and 21. And then after that, I am going to make another object, date2. You are going to call this constructor while it is being built, constructed, month value. What is it? Initialize the date to the first of the given month. So if the month value is 5, May, so this is going to be May 1st because it sets the date to 1. If I call this one no parameter constructor, okay, it will initialize date to 1/1, January 1st. So that will be it then. This will be February 21st, May 1st, and January 1st. How about this one? This one will make 100 day of year objects. But which constructor will be called? Efendim Nadir Bey?
Hocam selamünaleyküm, günaydın.
Aleykümselam. Buyurun.
Nasılsınız hocam, iyisiniz?
Şükür iyiyim, bir dersteyim Nadir Bey. Acil mi?
O zaman hemen kısa söyleyeyim, kapatayım hocam. İSG kuruluyla ilgili dekanlık olarak bir bildirim yapılması gerekiyor, bildirime. Onu bu hafta hızlandırırsak süreç mühendislik fakültesini bekliyor sadece. İyi dersler, kolay gelsin.
Oldu, teşekkürler. So this one, line 38.
Same constructor as for line 37, but in 100 times.
Yeah. So it will call 100 no parameter constructors. It will call 100 of them this day of year. Okay. It will call 100 of them. But how about this? If I don't write such a constructor, then line 37 will give me an error message saying that no, this cannot be built. And line 38, the same thing again. It will tell me that you cannot make an array of this class because it doesn't have a no parameter constructor. Yes?
Is there a way to initialize array of objects calling the constructor?
Already constructed? Sure, yeah. I mean, I can do stuff like remember, I mean, this is no different than an integer the array, and I am doing this, and then you could say things like no, okay, d1 comma D2, comma D3. Okay, like an array initialization.
I'm asking that could we initialize an array of objects that call the constructor
With parameters?
yes,
Well, not array of objects like that, but maybe with the vectors you could, but in C++. Well, I mean, this is a kind of a way to achieve whatever you are saying in an indirect way, okay? So D1 is constructed using 2 parameters, D2 is with 1 parameter, etc. But no, you cannot, I mean, it is not that easy to say it. But with the vectors, yes. Remember the vectors? It is possible to have a vector of day of year objects, okay, V1, and with this one you could say I am going to use this constructor and these will be the parameters for those and etc. I forgot how to do that. It is defined by the vector stuff. Okay, so we looked at all 3 versions of it. Yes. Sure, I mean constructors are like regular functions. If they are regular functions, why can't I define a default argument list? You can do that, right? I mean, you can, when you say 1 and 1, okay? So what does that mean? It means that if you give me 2 values, I am okay. If you give me 1 value, I am okay too. If you give me 0 values, I am okay too. But if you give me only 1 parameter, then this and this will be in ambiguity, right? The compiler will not know should it call this one or that one. Okay. If it is 0, then it's going to be a problem. So maybe the best thing is just cancel these 2 out. Use just this. And it is exactly the same thing. It behaves exactly the same thing, right? If you don't provide any parameters, it will be month 1, day value 1. If you provide just 1 value, it will be month and day will be 1. If you provide 2, then it will be the same as before. So with the default arguments, it will be a much shorter code, elegant code, better behaving code maybe. Okay, yes, that would be a solution, good solution. Yeah, it's possible. The answer to your question is yes. Whatever you can do with an ordinary functions, almost all of them you can do with the constructors. Of course, they have their own differences, like what? They don't return anything, okay? And their names has to be the same as the class. And they are called automatically. You don't call the constructors yourself, okay? They are called automatically, okay? Here you are not saying that I am calling the constructor. You are saying that I am constructing a new object, date1, and the compiler calls the constructor automatically for you. Okay, yes?
Can we have a default function, member function calls in order to assign default today's servant month and day value?
No, what did I say? I said that you don't call constructors explicitly. This is not allowed. I think there was a place somewhere. Where is it? Where is it? The book talks about it.
I'm not talking about calling constructors. I'm talking about calling another member function inside of the type definition of argument of constructor.
Well, what did I say? I said maybe a set function should be called inside it. Are you talking about calling the set function inside this? Yeah, well, we already said that, right? You can call set function inside this constructor, yeah. Are you talking about calling it in the initialization section here? No. I mean, initialization section is only for initialization. It has to be a name of the variable, the member variable, okay, data member. Then maybe you can call a kind of validity check function inside this parentheses. But usually we don't go that way.
Is the assigned equals 1? Like, is the assigned...
Well, I mean, this is a special place. You don't get to run any code that you like in this. This is not a C statement block, okay?
Space, but in arguments section.
Even here?
Value equals set function something.
Well, as I said, inside these parentheses, maybe you can call functions, but that's something that we don't prefer much because this is supposed to be simple. Just one value there and one value there, etc. Okay. If you need to do those kind of stuff, you do them inside these curly braces, like a regular C function. Okay. Yes. Can I use real numbers? You mean constants, literal constants? Yeah, sure. Let me show you that one. Yeah. Why not? I mean, let's see the implementation of those functions. See this one, month value, day value. They say that month value will go to month, day value will go to day, and I'm going to test the date to see if the date is right. For a single one, month value will be this, day value will be 1, like you said, and I'm testing the date. For no parameter constructor, month will be 1, day will be 1, and I don't test the date because I know that 1 and 1 is a valid date. Right? And by the way, this private test date, it is private. Since it is private, I can only call it from the function, member function definitions. It just says month should be between 1 and 12, day should be between 1 and 31. If there is something wrong, then I will exit. Okay, did everybody sign their names? Everybody signed their names, I guess. Let's see how many people we had. Oh, I don't have permission. I am not connected to the internet. Okay, let's connect to this one. Let me read a few names. Did you have this problem? I cannot connect to it. I mean today. So what did you do when you did have the connection problem?
I use my own internet.
What?
I use my own internet.
Now, did you report it to anybody? If you keep doing that, nobody will fix anything.
Actually, on the dormitory, we have been reporting for 2 years, but nobody did anything.
Well, I don't know about your material. This is different, okay? What's happening? It is trying to. Okay. Where is my? It doesn't see any. My cell phone. Okay. This time I believe everybody is here. It will connect automatically in a few minutes. Okay, here it is. Okay, it will come and I will read your names. So we talked about this and preferable definition. Constructor, not just initialize data, okay, but validate the data. Initialize it and validate it. Both of them are good object-oriented principles. No object will be uninitialized. No object will be invalid case, okay? If you have, it is okay in C, it is okay to have an integer like this. Because why bother if I am going to make this like that at a few lines later? I don't need an initial value for this. In C++ or in any object-oriented programming languages, we don't like these statements. I mean, say that even if you are going to modify it in a very short amount of time, you should always keep your objects initialized and valid. Okay, no invalid objects should exist. Okay, we talked about overloaded constructors. Like regular functions, constructors are overloaded too, and we overload them to make them more useful. Okay, and this was the example that I showed you. Okay, 2-parameter constructor, 1-parameter constructor. The book says it's a default constructor, but it's kind of not correct name. Okay, this is a no-parameter constructor. 2-parameter constructor, 1-parameter constructor, no parameter constructor, okay? Default constructor is something different, and we will talk about it in a few minutes. Default constructor is this, okay? Class A. Remember this one? My favorite class, okay? A. To make this object A, okay, to construct this A, the compiler has to call a constructor, but I don't have a constructor in there. The compiler makes an default constructor and it calls it. So there is a constructor in this class. It is the default constructor. It is constructed by the compiler automatically. It's called default constructor. Okay? So default constructor is not this one. It is the constructor in this one. The confusion here, it comes from that one. The default constructor doesn't take any parameters, and this one doesn't take any parameters. Default constructor is defined by the compiler automatically if there are no constructors available defined by the user or the by the developer. Okay, if I don't have any of these, then the compiler, if I have any of these three, I don't have it. Okay, the compiler will give me a default constructor. Of course, it's a no parameter constructor again. It doesn't take any parameters. That is called default constructor. So this is not a default constructor. This is a programmer defined no parameter constructor. And we'll talk about the default constructors in a few minutes. Good, and the rest of them is the same thing. Let's look at this one. I make 3 objects, date 1, date 2, and date 3. I'm using all of them. And they are nicely initialized. Okay. And line 30 is a very unusual line. It is compilable, it is done. We don't prefer it that way, but okay. This one is, you are making a temporary day of year object with these 2 values. That temporary object will be assigned to date 1. Okay? Will be assigned to date 1, and it will work. Remember this assignment operator, it works for for any class, because remember this one, A comma B, this will work. A gets the value of B. Okay, so the assignment operator works for this class, even though if I don't have anything in it. Assignment operator works, but this one will not work, remember? This one will not work. This is okay, this is okay. Okay, why do I say this is okay? This is okay because there is a default constructor. To make a constructor, to make a class to have objects of that class, it has to have a constructor. Without a constructor, you cannot construct an object of a class. So let me go to this example. Okay, let me go to this example and do this. Instead of public, I will make this part private. So now my constructors are private and my input, output, etc. So this is a very weird class. Why is it weird? Because I can't make objects of this class anymore because my constructors are private, right? To make a object date1 or date2 or d1, as a customer, I should have access to the constructor, but it looks like my constructors are private, so I can't make any of these objects. I can't construct any of these objects. They are all private. Okay, they are all private. Okay, so constructors are regular functions, almost regular functions, and they can be made public or private like the other functions. But you might wonder, what is the use of making a constructor private? We'll talk about that later when we talk about making dynamics objects and etc. Okay, and in fact this is one of the basic principles of object-oriented software design. Okay, try to hide your constructor. Don't let your customers freely make objects of your class without your permission and etc. You'll learn about them later in your third year. Okay, so make this again public. Okay, so we talked about those. I immediately jumped to that slide because this one has a public default constructor. Without a constructor, you cannot make objects. Good. Okay, I already showed you those. Constructor with no arguments. Okay, let's look at these two definitions. Remember, this one is the first one is the way we define objects with no parameters. Okay, no parameter constructor. The object is defined this way. If you do it this way, you will get a compiler error most of the time. What does this look like? This one looks like what? What? It's a function. It's a function. It doesn't take any parameters, and it returns an object of type day of year, right? Compiler says it this way. Okay. Compiler says it this way. It says that you are defining a function. You are going to define a function date. It will not take any parameters, and it will return this. So that's the meaning of it from C language. Okay. That's why we don't do it that way. We do it this way. Okay, that's how you make no parameter constructor calls. Okay, good. We don't call our constructors explicitly. For example, you don't say that. Let me write it. I think I thought I had it. Okay, day of year. Day of year D1 1 2 D1 dot, I can use set, get, print, output, input, and etc. But since constructor is a function member of this class, can I do this? Day of year, okay, 2 and 5, 7. The answer is no. No, you can't. You can't call your constructor on an object like this. I mean, you feel smart and you say that I am going to initialize my object. I am going to initialize my object, or I am going to change, set my objects values like this. No, this is not allowable. This is not allowable. But of course, as the book says, you could say this. D1 gets the value of day of year 2 and 7. So this is an expensive line. It will make a temporary day of year object, and it will assign it to D1. So instead of writing D1 this way, it would be much better to say set to 7. This will be much better than that. Okay? It will be much better than that. Okay, we talked about it. Okay, default constructors, we should talk about this, but I think I need to stop at this point. Any questions? I guess no questions. Okay, then that's it.